Today's lesson, we want to talk about the shape of the Earth, our planet. What shape is it? And you might know the word circle. Some of you might know the word sphere. It's kind of shaped like a ball. This is what we call a globe. We say that the Earth is round. These are all words that help describe our planet and its shape. If you look at the picture that I've shared, you see that we see half of the Earth at a time. And that's because half of it points toward the sun and half points toward space. So at any time, at 8 in the morning, half of the Earth is getting sunshine. At midnight, half of the Earth is getting sun. And the moon is the same. We don't always see the whole moon lit up, but the moon is always half with light and half with dark, 50%. So I like to use the term sphere. Sphere talks about a three-dimensional round object. And yes, the Earth is round. Some people say, no, it's not, it's flat. They're wrong. It is definitely round. And so I wanted to show you some reasons why today. We call that proof or evidence. Why is the Earth round? The first one is this idea of a ship. If we watch a ship going out to sea, the farther away the ship gets, the lower the ship looks. And that's because it's going around the Earth. If it went out flat, we would see the whole ship just get smaller and smaller and smaller. But instead, we see it dip as it goes around the curve. Another one is constellations. If the Earth were flat, we would all see the same stars. But that is not true. In North America, we see stars up here, and in Australia, they see stars down here. Way different stars, because we're not flat. If we were flat, everybody would see the same stars all the time. Those are called constellations. We have something called an eclipse. An eclipse is when the moon and the sun line up and the light gets blocked. And here you can see the shadow. We know shadow, right? Makes a dark spot. The shadow of the Earth is round. That's all the proof we need. The ancient Greeks 2,000 years ago saw this. They knew that the Earth was round from its shadow. And of course, we've been to space. We went to space and we took a picture. And you can see the picture from space that shows us the Earth is round. We can also measure it with math. If you stand on different places on Earth, your weight changes, not your mass. Your mass is the same, how many atoms you are made of. But your weight can go up or down. And it has to do with how close you are to the middle of the Earth. If you're at the North Pole, you are actually a little closer to the center of the Earth, and it pulls down on you. That's called gravity. And so you weigh a little bit more at the North Pole. You weigh a little bit less, you're farther away. You weigh a little bit less at the equator. The same thing is true on a mountain. You're farther away, you weigh a little bit less. If you go all the way to space, you weigh almost nothing, 0. If you are on the beach by the ocean, you are closer to the center of the Earth and you weigh a little bit more. So when we talk about weight, sea level, you weigh more. Mountains, you weigh less. At the poles, you weigh more. And at the equator, you weigh less. So what does all of that actually mean? It means that the Earth is not a perfect circle. The Earth is actually squished a little bit. If we go around the poles, it's only 12,700 kilometers and 14. If we go around the equator, it's fatter. It's 12,756. Is it a big difference? No, it's a little difference, but enough that we can measure it. It's actually called, there's that word sphere again. Our true shape is oblate spheroid. Oblate spheroid. You don't have to unmute, but I want you to say that out loud at home. Oblate spheroid. Let's say that one more time. Oblate spheroid. And what it means is that the poles are a little bit squished. This ball does a good job of showing it, right? The poles are squished, a little bit flat, and the middle bulges out. And the reason that happens is because the Earth spins. And that's called rotation. The Earth spins. If you ever take your cereal, if you make cereal and you pour in the milk and you spin around the milk inside, the milk goes out to the sides. And so when we spin the Earth around, it goes out in the middle. And the name of that is oblate spheroid, more like an oval instead of a circle. We understand the shape of the Earth and the layers of the Earth and the density of the Earth. That's what you need to know from the first couple of weeks. I'll see you on Monday. Have a good weekend.